Welcome back, Hononegah, Honors Algebra 2, starting off our first section out of the book. We just completed our pre-chapter. Section 1.1, talking about parent functions and transformations. This is actually a very important lesson because transformation is something we're going to talk about throughout the entire first semester. And so we got to make sure that we are locked in today. Functions that belong to the same family share characteristics. So the parent function is the most basic function of a family. And so functions in the same family are transformations of their parent function. So again, we're looking at the most basic function of each particular family. So the first one is just a constant. So if you had like y equals 1 or y equals a number, that is a constant. It's a line that goes straight across. There is no variable other than the y. So y equals a number would be a constant function. The domain is the x values. Range is always the y values. So when you're looking at a function, you should always look at what x values are you allowed to have. And as you notice throughout all the functions that we're dealing with right now, the domain is all real numbers because you're allowed to put any number in for x in each one of these functions. So the range, if you have a line going straight across, the range will always be y equals whatever number you're talking about. So that's because it's only going across at that particular y. A linear function, x value raised to the first power is a linear function. And so all real numbers, and again, all real numbers because it goes left and right. You're allowed to use any x value that you like, and it goes up and down. So you're allowed to use any y value there. An absolute value function, obviously that's pretty self-explanatory. We just got a y equals absolute value of x. All real numbers again because you're allowed to use any number for x. And y is greater than 0. Now we're going to talk a little bit about that. Remember when we talked about cusp earlier in the pre-chapter, so the y value is going to be greater than or equal to that value. Now it could be less than or equal to if you have a reflection and the absolute value is going down, and we'll talk more about that in a little bit. Quadratic, that's when you have an x squared, and so all real numbers then, and again, the same situation, you have a vertex instead of a cusp. Okay, so that's the lowest or highest point, just like the cusp would be on an absolute value function. So here we go. Identify the family. So I'm looking at this and I see the function y equals 2 absolute value of x plus 1. So this is definitely an absolute value family. And then they want you to talk about what's happening here. Now here is the most basic parent function. I'm going to draw this in here so we can compare it. And then we haven't really talked about the transformations and stuff yet, but we want to kind of look logically here as what happened. So look at the cusp. It's here, and now the cusp is up there. So you're talking about what would be called a translation, or it went up 1. Okay, we would call this a translation up 1, but just looking at it right now, this particular graph went up 1. Now, you'll also notice that the parent function is wider than and so this is what they call a stretch, and what's known as a vertical stretch. And again, what caused that vertical stretch, or what caused it to go narrower as the graph went, is the 2 there. So because you multiplied by 2, that caused a vertical stretch. And because you added 1 at the end, that caused a translation up 1. And we're going to get more into that and more specific into that here in just a second. A transformation is a general term. All of these are going to be called transformations. Transformations changes the size, the shape, the position, or the orientation of a graph. Now, specifically, a translation is a transformation that shifts the graph horizontally or vertically, but does not change the size of the graph. So if I have a graph, and all I do is move it, it's the exact same picture, and even though I didn't maybe make the exact same picture, this particular graph was translated from this point to this point. So again, you are not changing the size, the shape, or the orientation of the graph, you're merely moving it. That is called a translation. Now, how does a translation work? Well, if you have a parent function and you add or subtract something to it, that is a translation. So now, I want to graph the parent function. This is an absolute value. So here's what I want to graph for the parent function. Y equals absolute value of x. So the parent function has a cusp at 0, 0, and then points. That is the parent function. And you can use a graphing calculator. Those of you that have a graphing calculator can go to the y equals function in the graphing calculator. Some of you are going to ask, well, where in the world do I find absolute value bars? It's under math, number, N-U-M. So you have to arrow to the right one. And then that will allow you to type in the absolute value at ABS, absolute value of x. And x is located by the green alpha button. All right. So now, what would this function look like? I'm going to make an XY chart. The cusp would be located at 0. We talked about this in the pre-chapter. Whatever value makes inside the absolute value 0. Now I'm going to try some other numbers, plug those in, so that I can get a good picture here. So if I plug 0 in, I get -4. I plug 1 in, I get -3. 2 in, -2. And then I do absolute value. Make sure you take the absolute value. And I graph the new function. So what happened in comparison from the original or parent function to the new function? And what happened is this was a translation, and you must use the words translation, down 4. So if you subtract 4 from a parent function, you are doing a translation down 4. Next one. Now, what happens if I do something inside the absolute value? I'm going to do the parent function one more time. So this is the y equals absolute value of x graph. So you get points like 1, 1, 2, 2, 3, 3, -1, 1, -2, 2. Okay. Now I want to graph this one. Where does the cusp start? Well, the cusp starts at -2. Remember, the value of x that makes what's inside the absolute value equals 0 is where the cusp will occur. That happened. We did that in our pre-chapter. So now, other values like -1, 0, -3, -4, and I plug those in. So I get 0, 1, 2, 1, and 2. So graphing those. So now, you'll notice that it doesn't change the size of the graph or the shape of the graph. It just shifts the graph. We don't say shift, we say translation. And then what did it translate? It went to the left 2. Now, I want to talk a little bit about that. Anytime you have something inside your absolute value or even inside a parenthesis, that is a shift to the left and to the right. Now, it's opposite of what you might think. If you're adding 2, it's to the left by 2. If you're subtracting 2, it would have been to the right by 2. So again, translating up and down, okay, is when you're adding or subtracting to the end. Translating left and right is when you're adding or subtracting something inside the absolute value. Reflection. Reflection is a transformation that flips the graph over the line of reflection. The reflected point is the same distance from the line of reflection as the original point on the opposite side of the line. Now, in this particular class, we are only reflecting reflections on the x-axis. What that means is if I have a graph and a point up here, then I'll have the same point on the other side of the graph. That would be a reflection on the x-axis. We will do some reflections on the y-axis. And yes, it is important for you to understand the difference between the two. If I have reflection on the y-axis, if I have a point, then I will have another point reflected on the other side of the y. So again, reflection on the y or reflection on the x-axis. All right. If you multiply the parent function by a negative, so you had a negative out in front here, that is a reflection on the x-axis. Now, I want to do the parent function, y equals x. Y equals x has the point 0, 0, 1, 1, 2, 2. All right, I apologize in the break here. I was interrupted, but I'm back now. The parent function, y equals x, we're going to graph that. And then I'm going to graph y equals -x. And you'll notice that the y equals -x line, as I graph this, is a reflection on the x-axis. So every point up here has a mirrored point below on the x-axis. So point here, point here. And now, technically speaking, this is a reflection on x and y, but I don't want to confuse you on that. So again, we're going to talk about this as a reflection on the x-axis. Another way to transform a graph would be to multiply the y-coordinates by the same positive value. When the factor is greater than 1, it is a vertical stretch. When the factor is less than 1, or between 0 and 1, I should say, it's a vertical shrink. Notice there's no negatives here because the negative was a reflection. So you're only talking about multiplying by a positive value. So if I multiply by a number greater than 1, that is a vertical stretch. If I multiply by a number less than 1, but not negative, that is a vertical shrink. So here we go. Notice we are multiplying by a 3. So even though I haven't actually graphed this or looked at it, I know this is a vertical stretch. Now, what does the actual graph look like? Well, the apparent function would be y equals x squared for a quadratic. So 0, 0, 1, 1, 2, 4. And now, what would the vertical stretch be? Well, I'm going to do an XY chart, probably be the easiest way for you guys to understand it at this point. There is a shortcut method that I will probably do for the in-person, but for simplistic purposes, I will do it with an XY chart. You can use a graphing calculator here. Just go to the y equals button and hit 3x squared. So now 1, 3, 2, 12. This would also be 3. This would also be 12. So now graphing those. Notice it didn't move the vertex. So 0, 0, still the vertex. 1, 3, and 2, 12. So notice it is stretching this graph vertically. Okay, it's taking the points on the graph and multiplying it by 3. So notice this was the point 1, 1. And this is the point 1, 3. So it's 3 times as high. This was the point 2, 4. And this was the point 2, 12. So you're basically multiplying all the y values by 3, which causes the vertical stretch. And when I say vertical stretch, I really should say by 3. So again, saying what you are actually stretching it by. Absolute value graph. So again, my parent function for an absolute value graph is y equals the absolute value of x. So 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2, and so on. Now let's graph the actual graph here. So I'm going to do an XY chart. The cusp at 0, 0. I can plug other numbers in, and I talked about this the last time. Instead of going by 1, I'm going to go by 4. The only reason for this is so that I don't get, anytime you have a fractional value that you're multiplying by, your increments of your XY chart should really be by the denominator. So if I plug 4 in, I get 3. I plug 8 in, I get 6. Negative 4, remember when you're doing the absolute value, you get 3 again and 6 again. So I'm going to graph those points. So I have the point 4, 0. Oh, I'm sorry, I have the point 0, 0, the point 4, 3. And then I have the point 8, 6. Three, 6. And I notice this is not a very big vertical shrink, but it is pushing the graph downward. Okay, so the original graph is in blue there, and the next graph is the black one. It is a vertical shrink, so it has pushed the graph downward by a factor of 3/4. So notice it's real close because 3/4 is kind of close to 1, which is, again, not a very large vertical shrink. This is a graphing calculator exercise. Again, if you don't have a graphing calculator, you can also use programs like Desmos on your computer. Y equals negative 0.25 x squared plus 4. I want you to type that into the y equals function on your graphing calculator, and then I'm going to describe. So I'll give you a second. You want to hit pause? All right, welcome back. So this negative sign means something, the 0.25 means something, and the 4 means something. So each one of those means something different. The negative sign is a reflection on the x-axis. The 0.25 is a vertical shrink by 0.25. And then the 4, and I'm going to move this down here a little bit, is a translation up 4. The table shows how many miles y you are from home after x hours. What type of function can you use to model the data and estimate the distance after 4.5? You will notice, okay, 150, 2, 93, 130, 4's back to 90, 5's back to 50. So you're talking about a quadratic, okay? Sorry, you're talking about an absolute value function. So it's actually going up in increments of 40. I mean, if you actually wanted to write this absolute value, and it's negative. So there's what the actual function would be if you wanted to type that in. That's what you would get. So negative 40, absolute value of x minus 3 plus 130. So this is an absolute value function. You won't be required to make that absolute value function, by the way. What would you expect 4.5 hours to be? So again, I'm looking at 4 and I'm looking at 5, and halfway in between, you're talking about 70 miles. Homework assignment is our first book assignment of the year. We've done nothing but worksheets in the pre-chapter, so if you have any questions, make sure you talk to your teacher, and good luck.